Okay, sorry. Okay, again go to this one. Okay, next. Okay, how you get this month access? You can start course. Start course. Click the start course, and if you pay your class fees, only class fees, no any additional fees here. If you paid, I think by cards, no. If you paid card, no any additional fees. Okay, you can again fill these spaces. Fill these spaces. If you paying by your bank card, you can go with pay here, Visa or Mastercard or any type of card given here. You can use for the class fee. Pay your class fees. Okay, Master, Visa, Easy Cash, M Cash, internet banking with pay here, whatever. Okay, the if you pay same as previous in direct bank payment, you can get direct bank payment here, then join course, then you can see all bank details here. Your bank details already you know. Okay, these bank details you can pay and you can send the screenshot, then you will have access to this page. Understood? Any doubt? I got the basic idea. No, you can try this. You can try this actually. If I explain it, I know it is not fully understand. You can practice. You can go to the page and you can practice. Okay, I got. All send me for last month. Send me a request. Send me an order. Then I will approve if you pay it. Okay, any doubt about website? Quickly. If you have any doubt, please ask me in WhatsApp. Then I will help you, and I will upload another video how to register in each page, in each class page, and show you everything. Okay, understood? Dihini, you have to order this. Okay? You send it. I will give you access. Yeah, I have now 13 orders. Yeah, lot of orders. After class, I will give you access. Okay. Yeah, I have a lot of orders now. I will access after just after finish class. I will upload. Then you can refresh and you can check if there are any doubt. If there are any problem, please ask. Yeah, Fatima, your orders also received. I will access. I will give you access. Okay, that's all about website. If any doubt, please ask in WhatsApp. I will help you within from when we go to next month. It will be normal. It is very easy. I think it is a good method. Every learning materials, everything you it is on not only for 1 month. It is if you got one page, it is the access up to exam. Entire 2 years, it is valid. Therefore, I think it is very helpful for you to find our all learning materials in one place. Only you need to pay class fees, no any additional fee. Okay. Now any doubt? No. Okay. Okay, today we're going to start our new lesson. This is our 10th lesson. Actually, this is our 10th lesson. I will show you before start the class. I will show you what are the lessons we completed up to now. Yeah, this is this one. Okay, this is our 2026 class completed lessons. Okay, 9 lessons completed. The area and volume, measurements, forces. The force is the bulk lesson. The work, energy, and power, trigonometric ratio, rotational motion, area and volume, biomolecule and mechanical properties of matters. Last month I completed. Then today we start our 10th lesson. This is the most important lessons. Okay, now I am going to stop this. They are the lessons we covered in the class up to now. Okay, last week area and volume, the work, energy, and power before last month completed. Okay, that's all about introduction. Okay, this is heat lesson. For this lesson, lot of calculation for this lesson. I have a tute, but I thought to not given to the tute give you a written note, same as mechanical property of matters. The reason is it has a lot of calculation, and this lesson is simple. If you understand the path of the structure of the lesson, if this lesson is very helpful, very easy. Therefore, I hope to give you perfect written note. Perfect written note. Prepare your note for this lesson. This is a in theoretically it is bulk lesson, but if you finally you will understand after the complete this lesson, it is a bulk lesson, but it is very simple if you understand the path of this lesson. Okay, this is heat. Write down, take your books and write down the topic heat. Heat, heat energy, heat energy, heat energy. Okay, I will give you a note, a perfect short note. If you want, I will give you the bulk note. Actually, it is too complex. Therefore, if you can prepare a perfect written note, it is very helpful for this lesson to understand, because this is the most important lesson of the syllabus. New students, old students, for all you, everyone, you can understand this lesson. It is a very new, anything we not completed in this lesson. After this lesson we start thermal chemistry. After that every lesson you have tute, and we only need to continue. This is our 2025 class now doing lesson thing. This is a cell structure. This is cell structure, and in 25 class we have only one lesson, that is environmental chemistry. The all tutes, the all 25 lessons covered in 25 class. Now in our 25 class only have the net what environmental chemistry. Environmental chemistry also the tute I have given for students. Then now 25 students have all 25 lesson tutes, and now our 25 if you see our 25 revision timetable, it is uh, not easy. It is too difficult timetable now we are doing. Now 25 students, now this is final 3 months. Now we have only SFT. They have 3 days per week, Monday, Tuesday, and today morning also we did a part of the cell structure lesson. Within this month, we complete cell structure and environment chemistry both. Then before 2 months, their syllabus is complete. Then we finally we only discussed full paper discussions in final 2 months. Now also only one day we discuss theory. Monday and Tuesday both we discussing papers and our exam papers and past papers. If you go to our YouTube, you can watch some of our revision videos. You can watch if you want. If you have time, you can watch, because next year you have to do everything. They're doing everything you have to do next year, not next year, within few months after their exam, you have to start your revision. Be starting your revision. Therefore, now you can complete your works, complete your lessons. Every covered lessons, try to complete by videos or whatever methods. Okay, it is not too easy. A final month, very difficult if you not completed. If you completed, you can practice questions and papers, and you can ready for exam very well, very easy. But if you not covered any lesson, any initial part lesson, it is too difficult to cover in last month. Remember that it is too difficult. Therefore, keep attention and try to cover maximum by our 27 class or any method. Now, if you want, we have a new group for 27 class. 27 class now. In the second group, we doing from the first lesson, measurement lesson. Now we are in the beginning. Only 2 weeks we did. If you want, you can join. Now 27 first group, we doing second lesson forces. This lesson 10th lesson. This class 10th lesson. Okay. Okay, enough. Okay, we're going to start heat lesson. This is the most important lesson, as I explained in the syllabus, and lot of calculation in this lesson. And this lesson is combined with our next 2 lesson. From after this lesson, from next month, we start our very important other lesson, thermal chemistry. That is thermal physics. The heat energy mean it is a physics lesson. It is actually we discussing about thermal energy in physical quantities, with physical quantities. It is a physics lesson. But in next month we starting the thermal chemistry. How this heat energy affect for the chemical reactions. That is our first chemistry lesson. We starting thermal chemistry. To understand fully thermal chemistry, the heat lesson is very important to get the basic knowledge for the thermal chemistry. Without this heat lesson, we can't go for the thermal chemistry. After that, we start another chemistry lesson. It is kinetic chemistry. The kinetic chemistry also, for kinetic chemistry also, we need this basic knowledge of the heat. Okay. Heat. Okay, do you know what is the meaning of this heat energy? What's the meaning? You know different types of energy types. If you go to energy, energy types, you know the light energy, what else? Magnetic energy, light energy, magnetic energy, what else? Chemical energy, electric energy, mechanical energy. We discussed in the mechanical energy last, work energy and power. We mainly discussed about mechanical energy. Okay, you can see there are different types of energy types in the earth: light energy, magnetic energy, chemical energy, electric energy, mechanical energy. There are different types of energy. One of these energy type that we called as heat or thermal energy, thermal or heat energy. Heat energy that we discussing in this lesson. Okay, that is the energy type we discussing fully in this lesson. Okay, thermal or heat energy we discussing, that's the energy type. First of all, the thermal or heat is a energy type that you need to understand. The heat or thermal is a energy type. The heat is energy type, which is formed this heat. Now, if you consider a fire, as I show previous, think it is a fire. It's a fire. Now, from this fire, heat coming out, or heat is enter to this fire. What do you think? Heat coming out or heat enter to this fire? Heat energy go inside to fire or outside to fire? What do you think? Inside or outside? What is the direction of heat energy? Sanura, what's the direction of the heat energy? It is the heat energy transfer from outside to inside to out, from fire to outside. No answers. Yes, inside to out. That is the most important thing. Okay, you can understand that simply. What is the main heat source of our Earth? What is the main heat source of our Earth? Heat කොහෙන්ද එන්නේ? For our Earth, think this is our Earth. This is our Earth. If it is Earth, what is the main heat source? Kabir, what's the main heat source? Very good. The sun. The sun is the main heat source. Think this is our sun. This is sun. Okay, now how about the temperature of the sun? How about the temperature of the sun? How about the temperature of the sun? How about the temperature? This lesson is very interesting and very easy actually. Finally, you will understand. This lesson is more than mechanical property or work energy lesson. This lesson is too easy. What is the temperature of the sun? Normally, it is more than 6,000 Celsius. More than 6,000 Celsius, the temperature of the sun. Okay, how about the temperature of the Earth? If I'm asking without sun, if sun heat energy not coming to the Earth, how about the temperature? How about the temperature of the Earth? Earth temperature? How about? Amina? You know, some regions in the Earth, if you consider polar, the North Polar and South Polar regions, their sunlights are very limited. They fully covered with glaciers. Then how about the temperature of this area? Rehlan, how about the temperature of this area? How about the temperature? Yeah, it is minus. Normally, if no any heat energy coming from the sun to Earth temperature is, remember, it is minus 18. Minus 18 Celsius is the temperature. Minus 18 Celsius is the temperature. Now, from sun, if you can open, if it is open, always heat is transferred from, now you can understand, heat is forming due to this temperature difference. Now you can understand the distance from sun to Earth. due to this even due to this distance may distance එකේදී පවා heat එක එන්නේ, the heat transfer to earth due to this the temperature difference, huge temperature difference. Therefore you can understand the heat is always formed due to temperature difference, due to temperature difference from high temperature to low temperature, from high temperature to low temperature. When coming sunlight in daytime, how about the room temperature, how about the ambient temperature of the earth with sunlight? When with sunlight it is normally 37 to 35 35 to 40 ambient temperature. This temperature is coming due to it is 6000, more than 6000 Celsius. Some due to this distance, even this distance, heat energy come through the our atmosphere, then maintain the heat 35 to 37, 38 Celsius on the earth. On the earth, summer regions, other regions that can be changed, point to point the temperature can be changed. Normally this is the heat. Okay, now you only need to understand basic, you need to understand the heat is an energy type which is formed due to temperature difference. The heat is an energy type which is formed due to temperature difference. Okay, now I will take another example. Understand the basic, then it is easy. I'll take another example. Okay, there is a road. Think this is a road. Think this is A side and this is B side. This side temperature is 100. This side temperature is 200 Celsius. A to B or B to A heat is transferred. It is 200 Celsius. A to B or B to A heat transferring. Heat is formed from A to B or B to A. Quickly. Yes. The heat always formed. Good. Abhi, what happened? Good. Kabir, what's the answer? A to B. A to B or B to A. No. Not low to high. High temperature to low temperature, Kabir. Very good. B to A. Heat is always transferred from high temperature to low temperature. Due to this side, high temperature to low temperature, the heat is always transferred. Remember, high temperature to low temperature. The heat is an energy type which is formed due to temperature difference. Temperature difference, it is always transferred from high temperature to low temperature. High to low. Kabir, understood? It is always transfer from high temperature to low temperature. Okay, now tell me, think this side temperature is 200 now. A to B or B to A heat is transfer. Heat is forming from A to B or B to A. What's your answers? Try to get the basic understand, then it is easy for this lesson to understand other parts. Yeah, what do you think? Both side temperature 200. Both temperature 200. No, 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 no. Yeah, about heat, the basic knowledge is very low, you know. Okay, everything you can understand. I ask if these two both side 200, where to where? A to B? Oh, very good. Along this road, no any heat energy transformation because there is no any temperature difference. I told the heat is an energy type which is formed due to temperature difference. Then if it is no any temperature difference, no any heat energy formation. Understood? For heat energy, compulsory to have a temperature difference. If don't have temperature difference, no any heat energy formation. Okay, that's a basic knowledge you need to get about heat. Any doubt? Please ask. That's a basic. Okay, write down. The heat is a energy type. The heat is a energy type which is formed due to temperature difference. Due to a temperature difference. The heat is a energy type which is formed due to a temperature difference. The heat is a energy type which is formed due to a temperature difference. Due to a temperature difference. Second point, the heat energy always transfer from high temperature to low temperature. The heat energy always transfer from high temperature to low temperature. The heat energy always transfer from high temperature to low temperature. Second point. Okay. Then you can draw this one, and this is a heat energy direction. Heat energy direction. Heat energy direction. High temperature to low temperature direction. You can, if you want, you can draw another one. Both side 100 Celsius. No formation of heat energy. Okay, if any doubt, please ask. Only 2 point I explained. The heat is energy type which is formed due to the temperature difference. Heat always transfer from high temperature to a low temperature. High temperature to a low temperature. That's the basic of heat. Basics of heat. Kabir, I got the actual meaning because your previous rationale is wrong. The heat is always transferred from high temperature to low temperature, not low to high. Yeah, question. If both endpoints are same, if both endpoints are same temperature, so does it means the whole object is that temperature? Yes, yes. If it is both ends A and B both same temperature, that means the entire rod is 100 Celsius, then no any heat energy formation. No any heat energy formation. That you need to understand. If it is the midpoint is another temperature, think the midpoint is 50 Celsius. Now in both sides, now previous your answer is correct. Now from both sides, heat energy transfer higher temperature to low temperature from midpoint. But if it is same temperature, no any temperature difference, no any heat energy formation. That you need to understand in basic part in the heat lesson. Okay, complete. 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 Leila? Okay. Okay. Now, do you have idea what is the meaning of the temperature? The heat and temperature, is it same or different? What your idea? Yeah, I asking the basic small things in your day-to-day life. The temperature you measuring, no? The temperature and heat. What is the meaning of the temperature? Temperature. Temperature. What's the meaning? What's the meaning of the temperature? Remember, okay, understand this one. The temperature, you know, every matters. There are three main physical status of matters. No, every matters of the earth. think it is solid, and liquid and gases. Every matters, solid, liquid and gas, every matters are produced with, they made with molecules. Okay, the main building blocks are molecules. So if you consider about solids, their intermolecule bonds are more strong. Their intermolecule bonds are more strong, and their molecules are too close to each other, then, and their intermolecule bonds are too strong. Okay, they are intermolecule bonds. Intermolecule bonds mean the bonds between these two molecules. If we consider about the liquids also molecule close to each other, but they are intermolecule bonds less strong than solid. Intermolecule bonds less strong than solids, therefore they can more, that's why the liquid can flow along any surface, it can flow. The reason their intermolecule bonds less strong than the solid. In solid, they are fixed bond. Again, no any moment. If we consider about gas, atoms, molecules freely available, more spaces between molecules, and there are molecules between this molecule with two weak intermolecule bonds. Now you can understand, it has two strong intermolecule bond, it is a medium intermolecule bonds. Intermolecule bond between these two molecules. Gases, weak intermolecule bonds, and the spaces gradually increasing. The spaces to low spaces, medium level spaces, and high spaces between molecules. Okay, now what is the meaning of temperature? Everywhere solid, liquid and gases you can find. They are the main physical status of matters. Okay, that we can discuss in the mid part of the lesson. Okay, now what is the meaning of temperature? The temperature, it is the temperature is a measure about the heat energy. A measure about the heat energy that we called as the temperature. The temperature is a measure about the heat energy. A measure about the heat energy that we called as the temperature. Okay, now if any molecule, if any matter, if any solid, liquid or gas has more heat energy, understand its intermolecule vibration that we called as molecule kinetic energy. Increasing. Molecule kinetic energy increasing means if any object take more heat energy, simply understand, it is a little bit complex. When absorb more heat energy, what they do it, the molecule kinetic energy means their vibration is gradually increasing. Think when we increase temperature by 5 Celsius degree, it is increasing. If I increase 10 Celsius, it is more than 5 Celsius, it is increasing. Okay, therefore, when increase the temperature of any object, the molecule kinetic energy, their vibration is increasing. This molecule always they are vibrating with temperature, with heat, provide heat energy. This vibration is increasing. This vibration is gradually increasing. Okay, now the temperature is not an energy type. It is a measure about the heat energy. If any object has more heat energy, its temperature is high. The temperature is this kinetic energy amount, actually. The kinetic energy amount. the atom's vibration amount that we called as the temperature. It is a measure about the heat energy. If any object has more heat energy, the vibration is increased, therefore their temperature is increased. If any object has a low heat amount, think this one has low heat amount, its temperature is low. The reason is when it decrease the heat amount, their vibration is very low. Their vibration is very low. Vibration very low means the temperature is low. Therefore, the temperature is a measure about the heat energy, and it's represent the amount of molecule kinetic energy, and it's represent the molecule kinetic energy. If it is molecule kinetic energy higher, its temperature is high. If it is molecule kinetic energy is low, its temperature is low. Understood? They are the basic of heat. In the inside the lesson we discussing more advanced things. Have you got the basic? Any doubt? It means the particles are acting as the result of kinetic energy, like motion. No motions. It's only vibration. It's only vibration. Okay, I will explain about it's only vibration, Sandeep. It's only vibration. No motion. No more motions. It's only vibrations. According to in thermal expansion in the mid of the lesson, you will understood fully about the vibration and how we get utilize these vibrations for different process. Okay, the temperature and heat is two different things that you need to understand first. The heat is the energy type, the temperature is the measure about the heat energy. When increase the heat energy of any object, it's take more energy. Then when it is take more energy, it's when it is take more energy, when it is take more energy, it's the kinetic energy increasing. The kinetic energy increasing means the temperature increase. The actually the temperature is a heat energy. When increase the heat energy, its kinetic energy increasing. Therefore, the temperature of the object is increasing. Okay, write down the topic temperature. Write down the topic temperature. Topic temperature. Okay, write down. A measure about the heat energy of a measure about the heat energy of any matter. A measure about the heat energy of any matter called as the temperature. Called as the temperature. A measure about the heat energy of any matter called as the temperature. Called as the temperature. Second point, when increase the amount of heat energy of any matter, when increase the amount of heat energy of any matter, its molecule vibration is increasing. When increase the amount of heat energy of any matter, when increase the amount of heat energy of any matter, when increase the amount of heat energy of any matter, its molecular kinetic energy. Its molecular kinetic energy is increasing. Its molecular kinetic energy is increasing. Therefore, the temperature of the matter also 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 increasing. Third point. Third point. There are different types of temperature measuring instruments. 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 By getting the temperature value of any matter, by getting the temperature value of any object, by getting the temperature value of any object, by getting the temperature value of any object, we can get the idea, we can get the idea of the heat energy of this matter. We can get the idea of the heat energy of this matter, of this object, of this matter. We can get an idea about the heat energy of this matter. We can get an idea about the heat energy of this matter. Okay, I got the point. If we measure, think I have object like this. I have object like this. Think whatever shape object. This is object. Now I measure the temperature of this. Wait, Rehlan, I'll wait. Think that measure the temperature. Think its temperature is 50 Celsius. Now I can get some idea about the amount of heat energy contained in this available on this matter. If it is another object, think it is another object, its temperature is 100 Celsius. Think it is 100 Celsius. We can say more than this A object, this B white color object has more heat energy. We can get some measure. Understood? That's the temperature. The temperature is not the energy type. Heat is the energy type. You need to understand the difference between that. The heat, the temperature is a measure about the heat energy. It is not the energy type. Sometimes a lot of students doing this mistake. The heat and temperature, they consider both same. No, totally different. I got the difference. The heat is energy type, which is formed due to temperature difference. It is energy type. It's a wave actually. It is energy type. The temperature is a measure about the heat energy. By measuring the temperature, we can get an idea about this object contain how much of heat energy. Understood? Yeah, Tehlan, what is your question? Arnit, Teranit? Sandeep, I got the microwave. Okay. The microwave makes vibration in atoms. Therefore, friction occurs in it. So temperature increase in the matter. What's the question? What is microwave? The microwave is different, that you can understand after we discuss the magnetic energy. In microwave, it is a wave is formed due to magnetic and electric. Magnetic and electric. Actually, it's provide electric energy, then increase the vibration of the matter. Simply, I explain. We increase the electric energy, then increase we may provide electric energy, then increase the vibration of these matters. Then increase the vibration. What happened? Their heat, their temperature is increased. That's only the basic thing. But it's not only electric energy that's provide magnetic energy as well. Then it's complex. The process is complex, but simply that is the method. Rehlan, understood? We provide electric energy for the uh, microwave. You asking microwave oven, no? Yeah. Okay. Okay, write down examples. Okay, what are the temperature measuring equipment, instruments? We mainly use thermometers. Thermometers. There are different types of thermometers we can use for the temperature measurements. Write down examples. Mercury glass thermometers. Mercury glass thermometers. Mercury glass thermometers. Mercury glass thermometers. Second, alcohol glass thermometers. Alcohol glass thermometers. Second one, alcohol glass thermometers. Third one, digital thermometers. Digital thermometers. Digital thermometers. Okay, that is the basic of the heat lesson. First, now you already know what is the meaning of the heat. The heat, I will explain summary of this lesson again. The heat is an energy type which is formed due to temperature difference. Okay, the heat energy always transfer from high temperature to low temperature, not low to high, always high to low. The second thing, the temperature is a measure of the heat energy. If any object has more heat energy, its temperature is high. The reason is when increase the temperature of any matter, its vibration, molecule vibration is greater. Therefore, when increase the molecule vibration, its temperature is high. It is a measure about the heat energy. By getting the temperature of any object, we can understand the heat energy amount contained in this object. Okay, that's the basic of the heat lesson. Basic part of the heat. Okay, now we go into the first part. Actually, now we going to start the heat lesson. Now we going to start the heat lesson. Okay. In heat lesson, we mainly discussing about three main areas. Three main areas. Okay, that is heat, starting of the heat lesson, focus well. Heat lesson, we mainly discussing about three main areas. Three main areas. The first one is the thermal expansion. Thermal expansion. The first one is the thermal expansion. The second one is the quantity of heat. Quantity of heat. Quantity of heat. The final one is the thermal transformation. Thermal transformation. Thermal transformation. Thermal transformation. Thermal transformation. Okay, that is all about heat lesson, the entire summary of the heat lesson. In this lesson, we mainly discussing about three main areas. The first one is the thermal expansion. The second one is the quantity of heat. The final one is the thermal expansion. If you can complete within 5 to 6 weeks, the entire parts, thermal expansion, quantity of heat, and thermal transformation, the lesson is complete. Okay, write down a star point, red color star point. Write down. In this lesson, mainly discuss three main areas about heat. Three main areas about heat energy. In this lesson, mainly discussed three main areas about heat energy. Write down. Okay, draw this chart. Heat energy. First one, thermal expansion, quantity of heat, and thermal transformation. After this chart, you can write down the first topic, first subtopic, thermal expansion. Thermal expansion. Thermal expansion. Write down the first topic, thermal expansion. Thermal expansion. Okay, now, do you have any idea what's the meaning of the thermal expansion? What's the meaning of the thermal expansion? The first topic, thermal expansion. Thermal expansion. Okay, do you have any idea what's the meaning of thermal expansion? Thermal expansion. Thermal expansion. What's the meaning? Habib, what's the meaning? Thermally expand. thermally expand expand due to the heat energy. What's the mean? Thermal expansion. Fatima? Very good. Fatima, what's the meaning of the thermal expansion? What do you think? In general idea? Sandeep, what is the thermal expansion? Expand වෙනවා කියන්නේ. General idea? Very good. You did in O level, no? Increase the dimension of a substance. Very good. All are correct. That is the thermal expansion. Amina, what is expansion? The thermal expansion is good. All are correct. All are correct. The thermal expansion means think this is the original shape of the object. Original shape of the object. Think this is the original shape of the object. Now it is theta 1. Theta 1 is original room temperature. Okay, from room temperature, this is the original dimensions, the size. When increase the temperature, is its dimension changing. That means size changing. That we called as thermal expansion. When increase the temperature of any matter, its dimension changing. Okay, that's theta 2 Celsius. Its size increasing, the volume increasing, size or volume increasing. That we called as a thermal expansion. Okay. Now, can you imagine how it is happening? Now, thermal expansion, now you can already understand when increase the temperature, the size increasing, the volume dimensions increasing, that we called as thermal expansion. Now, in molecular level, in atom unit, atomic level, now you need to understand what is the meaning of this thermal expansion. Focus very well. They are the basic things of this lesson. If you understood this basic, others are very simple. Okay, thermal expansion means simply when increase the temperature, size increasing. Simple. Okay, now how it is doing in atomic internal structure, what are the differences doing? It should have a reason. It's without reason cannot increase the size, no, cannot increase the volume. It should have some reason. Okay, now as I explained earlier, every matters, solid, liquid and gas, every matters are produced with I have this, yeah, samely every matters is made with molecules or atoms. Molecules, see, atoms. Actually, try to get full idea. The molecules of atoms mean what? Even in our structures, our hands, our organelles are producing these molecules. Then what are these molecules? Molecules are the carbon, hydrogen, oxygen, nitrogen. They are the molecules in the periodic table. They are the molecules. Every matters is produced with molecule. Okay, molecule. They are the building block. The smallest unit is molecule. Okay, they are smallest unit is molecule. Now you know solids, liquid, and gases all made with molecules. Now you know in solids you already know they are internal intermolecule bonds are too strong and their spaces are too less amount of spaces. I'll write here, they are intermolecule spaces. Intermolecule spaces. Spaces to very low, and intermolecule bonds. Intermolecule bonds too strong. Intermolecule bonds too strong. Now I will explain about first solids, then you can get the idea how it is changing liquid and gases. First I will explain about solid. Okay, now I have whatever solid object. I have whatever solid object. Their internal structure is like this. Their internal structure is made with molecules, and they are very close to each other. Then it has strong intermolecule bonds and less intermolecule spaces. Now when increase the temperature, solid objects, when increase the temperature increasing, what happened? Molecule, what happened? Molecule vibration, molecule kinetic energy is gradually increasing. When increase temperature by 5, 10, 15, 20, like increasing, the molecule kinetic energy gradually increasing. Molecule kinetic energy, that's mean molecule vibration gradually increasing. When increase the molecule vibration, what happened? The gap between these molecule spaces gradually increasing, because for more vibration they need more space, therefore they increase between molecules, increase in their spaces. That's why its size is increasing, that's why its volume is increasing due to temperature increase. Their intermolecule spaces, they increasing a certain level. In a certain level they are increasing their spaces, that's why they are the between molecules, they are, the gap is increasing, therefore the volume or the size is increasing of solid objects. Understood how it is expanding? Understood? Okay, now think about liquids. Samely, think about liquid. What happened in liquids? If we consider about liquids, intermolecule bonds are medium. Intermolecule bonds are medium, and it has a medium level of space between molecules. When temperature increasing, what happened? Temperature increasing, liquids also increase in their spaces, molecule spaces. Now what happened? They are expanding. Their volume is increasing. The volume is getting increased. Okay, gases has two weak bonds between molecules. Now when increase the temperature, they are same, their internal vibration, their motions are increasing, kinetic energy increasing, therefore their spaces increasing, therefore their space, the gap increasing, therefore their volume increasing. That we called as a gas expansion. Okay, now I have question. Okay, think and give me rational answer. If we compare solid, liquid and gas, which one has most expanding capacity, most expanding ability? I need answer from all. Think, rationally think their bonds and space. Mainly think about their bonds, intermolecule bonds. Tell me which one has most, solid, liquid and gas, which one has most expanding capacity, expanding ability, capability? Good. Very good. Very good, Rehlan. Others? Fatima? Very good, Kabir. Amina, which one has most capability to expand? Very good. Very good. All are correct. Eh? Liquids? How you decide? You should have a reason. You should have a reason, Amina. Now think solid. Solid, their intermolecular bonds are too strong. Too strong. When you increase the temperature, they are the expanding ability is limited because they have too strong bonds. Too strong bonds. Therefore, when increasing the vibration due to these hard bonds, they cannot increase the more space. It is like this. They have bonds. I will show you. Uh, okay, think these they are two molecules. Now the bond between these two molecules is too strong in solids. Therefore, when we increase in the temperature, their vibration is increased. Vibration is increased, but between these, due to this bond, strong bond, they are expanding ability. The volume, the gap enhancing ability is very low. Okay. Now, if we consider about liquid, comparatively the bond is strong plus is less. The bond is less strong than solid. Therefore, when increase the temperature, they can expand, vibrate like this. They can vibrate like this. Okay, they can vibrate. If we consider about gas, they have two weak bonds and they have like this. Their spaces is too very high. Their gap is very high. Now, when you increase the temperature, they can expand like this. They can expand like this. They can vibrate like this. They can move actually, freely moving. They have more spaces. Therefore, the gases are the more capability to uh, expand. I mean, now understood? Yes. Due to this, the strongness of the bonds, intermolecule bonds, intermolecule bonds. Okay. Okay. That's the internally in atomic level, the expanding is happening due to molecular increase in the molecular spaces. Temperature increasing, their vibration increase. Due to vibration increase, their spaces increase. That's why it's the expanding is happening. The size is increasing. Okay, write down. When increase the temperature, when increase the temperature of any matter, when increase the temperature of any matter, its volume or size increasing. Its volume or size increasing is called as the increasing is called as the thermal expansion. 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 Okay, write down with red color star mark. Write down red color star mark. When increase the temperature of any matter, 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 its internal molecule, its internal molecules kinetic energy is increasing. Its internal molecule kinetic energy is increasing. Its internal molecules kinetic energy is increasing. Therefore, their vibrations increasing and therefore their vibrations increasing and gap between molecules increasing. Therefore, their vibration increasing and gap between molecules increasing. Gap between molecules increasing. Gap between molecules increasing. Gap between molecules increasing. Due to that, the volume of this matter is increasing. Due to that, the volume of this matter is increasing. That we called as the thermal expansion. 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 Okay, next star mark. Next star mark. When compare the expanding ability of solid, liquid and gases, when compare the expanding ability of solid, liquid and gases, solid, liquid and gases, comma, gases has more expanding capability. Gases has more expanding capability than liquid and gases. Than liquid and solids. Than liquid and solids. Than liquid and solid. The reason is gases has two weak intermolecule bonds. The reason is gases has two weak intermolecule bonds than liquid and solids. Than solid and liquids. Than solids and liquids. Okay, complete note. Any missing point in this lesson? That's only notes. Okay, that's only in initial parts only you have notes, otherwise no any notes. That I'm not giving a tune. Okay, complete tubes, notes. Anyone missing? Complete, no? Amina, complete? Yes. Okay. Okay, now you have to note down this one. Okay, then directly we go to the thermal expansion. Okay, that's in molecular level. I think you, if you have basic knowledge, if you have practical understand, imagination, that enough. Don't need to explain them. When increase the temperature, whatever solid, liquid and gases, their molecule atom vibration is increasing. Vibrate increasing, they are intermolecule spaces gaps increasing. That's why its size volume is increasing. That's the thermal expansion. That enough. Okay. Okay, write down this, the short note. Short note. We'll make a table. Solid, liquid. Okay, write down with me. Gas. Okay. IMB mean intermolecule bond. If you have space, you can write down the full name, or in other place you can IMB mean intermolecule bonds. Intermolecule bond. IMS mean intermolecule space. Intermolecule space. Okay. Expanding ability greater than solid and less than, if you want, less than gas. You already know that. Expanding ability greater than solid. Greater than solid, expanding ability in liquid, because it is intermolecule bonds medium. Intermolecule bonds medium. Final. intermolecular bonds. Too weak. Space very okay. That's a full short note of the lesson, basic part. Okay, make this table, and if you complete, please let me know. Complete. Please remember IMB mean intermolecular bonds. The short form IMS mean intermolecular spaces. Amina complete? You mean do? Udanne? Complete? Done, yeah. Are you done? Complete. Okay, Fatima, Khabir, done. No? Okay, good. Now, write down next point below the table. Write down next point. According to the matter type, you already know. According to the matter type, thermal expansion, according to the matter type, thermal expansion according to the matter type. Thermal expansion, mainly three type. According to the matter type, thermal expansion, mainly three types. Mainly three types. Write down the first one, solid expansion, solid expansion. Write down the second one, liquid expansion, liquid expansion. Write down the third one, gas expansion, gas expansion. Write down the third one, gas expansion. And write down the first subtopic again, solid expansion. Write down the first topic again, solid expansion. Solid expansion. Okay, understand this path. Okay, that will more important. These things are very simple. Understand the path the lesson is going. Then it is very simple to remember these things. According to the matter type, thermal expansion. In this lesson, mainly we discussing about thermal expansion, quantity of heat, and thermal transformation. That's the basic of the lesson. In thermal expansion, according to matter type, it is three types: solid expansion, liquid expansion, and gas expansion. Write down topic, solid expansion. Solid expansion. Okay, solid expansion, now you already know. When increase the temperature, the size of the solid objects, size of the solid object increasing, that we called as a solid expansion. Very simple. Okay, write down. When increase the temperature of any solid object, when increase the temperature of any solid object, its size increasing. Its size increasing is called as the solid expansion. Is called as the solid expansion. Is called as the solid expansion. Called as the solid expansion. Write down star mark. Solid expansion again, main three types. 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 Okay, remember, according to matter type, thermal expansion, solid expansion, and liquid expansion and gas expansions. Liquid and gas expansion we can discuss later after completing solid expansion. Now we're discussing about solid expansion. When increase the temperature of any solid objects, the size increasing, that we called as the solid expansion. Now solid expansion again we can divide into three types. Remember that first one, write down linear expansion. If you want, you can draw a chart, or you can write 1, 2, 3 like linear expansion, linear expansion, linear expansion. The second one is area expansion, area expansion. The final one is volume expansion, volume expansion, volume expansion. First one, linear expansion, linear expansion, area expansion, and volume expansion. Linear expansion, area expansion, and volume expansion. And again, write down the topic, linear expansion. Linear expansion. Linear expansion. Write down the topic linear expansion. Okay, what is the meaning of this linear expansion? It is very simple. The linear expansion, the first one. Now remember the path, otherwise it is too complex. Okay, this doesn't too complex because it is lot of classifications. Every part now, that's a large classifier. Now every part we need to discuss one by one. Okay. If you want, I will show again how it is thermal expansion classified. Thermal expansion. Again, mainly three types: solid expansion, liquid expansion, and gas expansion. Solid expansion, again three types: linear expansion, area expansion, and volume expansion. Okay, that's the classification. Understood? Okay, now we're going to discuss about this linear expansion, then area, then volume. After that, we're going to discuss that. Okay, come to linear expansion. Linear expansion. Linear expansion. Okay. What do you think? What's the meaning of the linear expansion? Linear expansion. Any idea? Sandeep, any idea what's the meaning of the linear expansion? Linear. In linear expansion. Linear expansion. Any idea? Okay, this is the linear expansion. Okay, if you got a rod like this, how we got a rod? Okay, think this is a rod. This is a rod. One answer. Increase in the heat when the object, increasement of the heat me, Sandeep, I can't clear this. Increasement of heat when the object substance heated. Yeah, heating, it's heat increasing. Is it correct or mistake here? Yeah, I think increasement of the height should be. Increasement of the height. Is it correct? Yeah, good. That's the answer. Increasement of the height or length when temperature increase, that is the linear expansion. Actually, if you consider about this type object, or like iron rod. In construction, we use the iron rods, uh, uh, this type objects. Do we have any can we observe when temperature increase, can we observe more area or volume expansion? No, only one dimension increasing, only one length is only length is considering. Okay, this type objects, this type expansion we called as the linear expansion. The expanding only in one dimension, only length, no width, only length. Okay, in area you can understand, area mean we considering length and width both. This is length and width both. But in linear expansion, only one dimension is considering, only one dimension is considering. Yeah, only one dimension is considering. When increase the temperature, the length increasing, one dimension, length or height. Correct, good. When increasing the heat, when increase the temperature, the heat increasing mean temperature gradually increasing. Then when increase the temperature of any linear object mean only one dimension object. Think it is the initial length is L1. L1 is this length. This length is L1. And its initial temperature is, think, 20 Celsius. Initial temperature is 20 Celsius. At 20 Celsius, its length is L1. Think when increase the length, when increase the length up to when increase the, oh sorry, think when increase the temperature up to 50 Celsius, 50 or 100 Celsius, think it is 100 Celsius. This is a theta 2, theta 1 and theta 2, I will explain later. Think it is increase up to, this is, think it is increase up to, this is delta L, the amount of increased length, the amount of increased length, and the total length is L2, final length. Final length. L1 is the initial length, the L2 is the final length. Okay, this is the length now. This is the length. This is the object. Okay, its length increasing, only one dimension, the length increasing. Only one dimension increasing with temperature, that we called as the linear expansion. Linear expansion. Linear expansion. Are you good? Any doubt? From only one dimension. If it is to go two dimension, that is area expansion. If we go three dimension area, that means length, width, and three dimension length, like this. Three dimensions like this, length, width, and height, both, it is volume expansion. If we consider only one dimension, that is the linear expansion, only height or length. Understood? Okay, write down. When increase the temperature, when increase the temperature, when increase the temperature, the amount of length or height increasing. The amount of length or height increasing within bracket one dimension. When increase the temperature, the amount of length or height within bracket from one dimension. Length or height increasing called as the linear expansion. Second point, there are three main factors affect on the linear expansion. There are three main factors affect on the linear expansion. Write down the first one, the initial length of the rod. The initial length within bracket L1. The initial length within bracket L1. The second one, the temperature difference. Between bracket delta theta. The temperature difference within bracket delta theta. Third one, the substance type. If you want within bracket matter type. Don't need any symbol. The temperature difference delta theta, initial length L1, and the substance matter type. Okay, complete everyone? Everyone completed? Good. Now understand, the thing is, this heat lesson, if you continuous come and complete this lesson is very simple. But the thing is, if you miss any part of this lesson, that's why I am asking again, complete, because without any part of this lesson, it is like a series. This lesson like a series. Now I think now you have idea, it is a series, lot of classification, and we discussing one by one. Therefore, if any part missing, then it is sorry.com's heat lesson. Okay, then again cannot understand. If you any part, if you late or if you miss next week class, again after you join again you can't understand. Therefore this is like a series. If you understood everything, it is very simple lessons. Okay, now you know there are three main factors affect on the linear expansion. The linear expansion is very simple. When this is the initial length, when you increase the temperature, the length is increasing from only one dimension. One dimension, length or height increasing. Okay, there are three main factors affect on the initial length, temperature difference, and substance or matter type. Okay, we'll take first one, initial length. When increase the initial length, what do you think? When increase the initial length, the thermal expansion is increasing this delta L. This delta L is a thermal expansion. This delta L is the amount of increase in length, increasing or decreasing. When increase the L1, L1, L1 increasing, I'm asking, when increase the L1, the thermal expansion is increasing or decreasing? Initial length increasing. Kabir, what do you think? When increase the L1, the thermal expansion is increasing or decreasing? That's L1, delta L amount. The length increasing amount is increasing or decreasing? Good, Rela. Good, Amina. Kabir, what do you think? Fatima, I'm asking. Now I have this is a object. Good. This is object. This is object. Now it's think within when increase the temperature by 10 Celsius, 10 Celsius, it is increasing some amount. Now it is length is double. What happened? Increasing amount increasing. Oh, same ratio. No, it is increasing. Remember, when increase the initial length of the substance or object, the increasing amount, the thermal expansion, linear expansion is increasing. The linear expansion is increasing. Okay, I will erase this part. No, I will take into site. There are three main factors. Okay, I will erase this part and I will write the factors in short way. The first factor is, second factor, the first factor is L1. L1 means initial length. The second factor is the delta theta temperature difference. Third factor is the substance type. Substance type. Substance type. Okay, now tell me, when increase the initial length, when increase the initial length, okay, very important, okay, initial length L1 increasing. Now understand these symbols, okay, L1 mean initial length, L1 mean initial length, L1 increasing, the delta L is what happened? Delta L is increasing, delta L is increasing. Therefore, we can explain delta L and L1 is directly proportional. Can you remember in previous lessons, mechanical properties, we discussed this type questions? Delta L increasing, sorry, L1 increasing, delta L increasing, then we can say delta L and L1 is directly proportional. Make a වැඩි වෙද්දි මේකත් වැඩි වෙනවා. Therefore, we can say both directly proportional. Directly proportional. Okay. Now, when increase the temperature difference, what happened to the linear expansion? What happened to the linear expansion? when increase the temperature difference. Now the given one, the temperature difference is 80 Celsius. If I increase up to 150 temperature difference, the thermal expansion, linear expansion amount increasing or decreasing? Increase the temperature difference. Delta theta increasing. Delta theta increasing. What happened to the delta L? Increasing or decreasing? Dihini? Increasing or decreasing? Delta theta now increasing. The temperature difference increasing. I'm asking the linear expansion, the delta L, amount of length increasing or decreasing? Very good. It's also increasing. It's also increasing. Delta theta increase, length, the delta L, the linear expansion increasing. Therefore, we can say the delta L also directly proportional with the delta theta. Delta theta they are directly proportional. Okay. Now, this is our relationships. This is our relationship. Now we can get another relationship. Now both directly proportional. Therefore, I can say delta L directly proportional to the L1 delta theta. L1 delta theta, because both directly proportional. Both directly proportional. This is the proportional mark. Okay, this is proportional mark. This is proportional mark. Okay, I'll change this. It is not the alpha, it is proportional mark. It is proportional mark. It is proportional mark. Delta L directly proportional to L1 delta theta. Now I need to remove this proportional mark. What we can do? In physics, always, if you want to remove the proportional mark, we need to add a constant. We need to add a constant. Now I am going to delta L equal to L1. I'm going to add a constant. The constant is alpha. The two different alpha delta theta. This is my first equation. This is my first equation. Delta L equal L1 alpha delta theta. Delta L equal L1 alpha delta theta. Delta L equal L1 alpha delta theta. Now tell me, what is the meaning of the delta L? What's the meaning of the delta L? Linear expansion. L1 initial length. Alpha we can discuss later. Delta theta temperature difference. Now what is the meaning of this alpha? What's the meaning of this alpha? Anyone? What's the meaning of this alpha? Remember, the alpha is the linear expansion coefficient. This is most important one. This is the linear expansion coefficient. Linear expansion coefficient. Linear expansion coefficient. Coefficient. Linear expansion coefficient. Linear expansion coefficient. This is the alpha is the linear expansion coefficient. Okay, now write down very carefully, very clearly. Write down very clearly. This one, draw this one L1 and L2 is the full final length. The delta L is the amount increasing length. Then name this as theta 1. Initial length is theta 1 and the final length is theta 2. Okay, draw this and mark the symbols correctly. and the delta theta mean the difference. Okay, the difference. Okay, write down very clearly, write down. That's the most important point you need to understand. Then the first equation is made. If complete, please let me know. Complete. Lihini, complete. Good. Now, I think you have problem now. I told there are three main factors affect on the linear expansion. Do you remember? I told there are three main factors affect on the linear expansion, but only we got two. Only we got initial length and temperature difference. What happened to next one? Substance type. The substance type is the alpha, remember. The substance type is the alpha. The linear expansion coefficient is it is a constant that depend on the matter type or substance type. Okay, write down the subtopic linear expansion coefficient. linear expansion coefficient within bracket alpha, linear expansion coefficient within bracket alpha, linear expansion coefficient within bracket alpha. Okay, write down the first point. The alpha is a, that means the linear expansion coefficient is a constant that depend on the matter or substance types, that depend on the matter or substance type, that depend on the matter or substance type, that depend on the matter or substance types, that depend on the matter or substance type, that depend on the matter or substance types. Second point, it means when change the substance type, the linear expansion coefficient is changing. It means when change the substance type, the linear expansion coefficient alpha is changing. Write down examples. Examples for copper. Copper, the alpha value is 5 into 10 to the power minus 5 or 6, 10 to the power minus 6 per Kelvin. If you got aluminium, its value is different. 6 into 10 to the power minus 6 per Kelvin. Okay, examples. The matter to matter type changing, the linear expansion coefficient different, varying. Okay, varying, that is given in the exam. I will explain in the calculations. That is always given in the exam. Okay, complete. Okay, now okay, what is the linear expansion coefficient? Now if you can you okay, if you can you isolate this linear expansion coefficient? I will erase this part. Okay, now I'm going to isolate the delta L equal L1 alpha delta theta equation. I am going to isolate this alpha. If it is isolate, I can get alpha equal delta L over L1 alpha L1 delta theta, no? Delta L equal L1 delta theta. Okay, carefully understand this part. Okay, from this equation, we can make a definition for the linear expansion coefficient. Now the same equation, I isolate the A alpha. Okay, not A, alpha. Okay, do you know what is the meaning of the velocity? The velocity equal displacement over time, no? The displacement over time is over time. This over time. Then we call the velocity is the displacement within unit time, no? The always the below one is the unit time. The same mechanism, the same process. The linear expansion coefficient, we can describe the amount of unit length when increasing the temperature by 1 degree, the amount of length increasing, that we called as the linear expansion coefficient of this substance, of whatever substance. Again come unit length when increasing the temperature by 1 degree. 1 meter increasing the temperature by 1 degree, the amount of length increasing amount, delta L, we called as the alpha. Understood? Trehlan? Understood? When increase unit length of substance, when increasing the temperature by 1 degree, the amount of length increasing amount we called as the linear expansion coefficient of whatever particular substance. Substance, this value is different. Understood? Amina? Okay, write down this equation again. Write down this equation again. First of all, isolate this alpha. Then I will explain. Isolate this alpha and this two step. Then you can find the unit of this alpha. Find the unit of this alpha. Unit of alpha. Unit of alpha. Unit of alpha. The meter, the delta L is standard unit meter. Delta L is standard unit, that's a length difference. It is meter. Divide by L1 standard unit initial length, meter. Delta theta standard unit is Kelvin, because temperature standard unit is Kelvin. Temperature standard unit is Kelvin. Meter to meter cancel out. The Kelvin need to get upward. It is per Kelvin is the unit. Per Kelvin. Per Kelvin is the standard unit. Per Kelvin is the standard unit. Per Kelvin. Per Kelvin is the standard unit. Per Kelvin is the standard unit. Per Kelvin is the standard unit. Okay, write down complete. Unit tech complete. Dihini up to now okay? Okay, write down with star mark, red color star mark. When increase the temperature by 1 degree, when increase the temperature by 1 degree of unit length of any substance, when increase the temperature by 1 degree, 1 degree mean 1 Celsius, of unit length of any substance, of unit length of any substance, the length increasing amount, the length increasing amount within bracket delta L, length increasing amount called as the linear expansion coefficient of this substance, called as the linear expansion coefficient of this substance, called as the linear expansion coefficient of this substance, called as the linear expansion coefficient of this substance, called as the linear expansion coefficient of this substance. It is depend on the substance. Okay, this value is unique for this substance. When change the substance type, the linear expansion coefficient is varied. Okay. Okay, now you have two equations. This is the first equation. Using this equation, I got this one. Okay, this one don't need to remember. That's on the isolation. Okay, therefore you don't need to remember this one. Okay, final point of the linear expansion. Final point of the linear expansion. Final point of the linear expansion. Now 9:25. We need to do one calculations also. Therefore, don't we take additional 10-minute time. Is it okay? Can I get additional 10 minutes? You don't have another class, no? Today? Okay. Now if I write like this, focus, okay? If I write, මම මෙහෙම ලිව්වොත් හරිද කියලා බලන්න. If I write L2 equal L1 plus delta L, is it correct? L2, that means final length equal L1 plus delta L. Correct name? L2 equal L1 plus delta L. It's correct. Now you already know delta L value. The delta L value is L1 alpha delta theta. Now I am going to add L1 plus delta theta. Instead of delta theta, I am going to use this expression. This expression. L1 equal, instead of this delta theta, I am using L1 alpha delta theta. Delta theta. It is same. Now you already know the L2 equal L1 is common to both. Then L1 1 plus alpha delta theta. A new equation is coming that is important for to get the L2 directly, to get the final length directly. Okay, write down subtopic, get relationship to calculate the final length. Get a relationship to calculate the final length. Get a relationship to calculate the final length. Get a relationship to calculate the final length. And write down this one. Get a relationship to calculate the final length. Within bracket L2. For L2 calculation, this is the equation. Final length. Okay, write down the question number 1. Simple question, only one question we doing. Then after that, next week we can discuss more questions. In next week we complete the expansion part. Expansion we only discuss in 2 days. Then expansion part we can complete the next week, and next week after that we start the quantity of heat. Quantity of heat is the most important part. Lot of exam marks coming in the exam question coming from the quantity of heat, second part. Okay, therefore don't miss any part, don't miss any small part, otherwise it is a huge damage for your understand, because it is a like series. Then all I think you can get Now you understood up to now, from beginning to up this point, it is like a series. If you miss any point in the mid, you can't understand. Okay, write down question number 1. There is a copper rod. There is a copper rod with 2-meter length, with 2-meter length, with 2-meter length at 30 Celsius. At 30 Celsius. At 30 Celsius. Within bracket, the linear expansion coefficient of the copper, the linear expansion coefficient of the copper, that's mean alpha of the copper, alpha of the copper, 5 into 10 to the power minus 5 per Kelvin. Per Kelvin. 5 into 10 to the power minus 5 into 10 to the power minus 5 per Kelvin. Question part A or part 1. Question part A. If increase the temperature, if increase the temperature up to 50 Celsius, if increase the temperature up to 50 Celsius, if increase the temperature up to 50 Celsius, calculate the linear expansion of the copper rod. Calculate the linear expansion of the copper rod. Calculate the linear expansion of the copper rod. Question part 2. Calculate the final length of the copper rod. Calculate the final length of the copper rod at 50 Celsius. At 50 Celsius. Calculate the final length of the copper rod at 50 Celsius. 50 Celsius. Okay, can you do this? Do you need to help? Do you need a help? Okay, I will help you for first question. Okay, what is question asked? If you draw a figure, I think it will more helpful for your calculation. Okay, first of all, can you draw a same type figure again? Same type figure again. The theta 1 is the initial temperature 30 Celsius. The theta 2 is 50 Celsius. 50 Celsius. L1 is given. The L1 is 2 meter. L2 or delta L, we don't know. That's asking the exam question. Delta L and L2. Okay, question part 1. Question part A. Calculate the delta L. Calculate the delta L. How we get the delta L? How we get the delta L? Okay, do we need some time for try this? Okay, I will give you 1 minute if you compulsory to draw this. Okay. Okay, we'll try. Kabir, I got anyone? Fatima? Only substitute values. The delta L value is okay. We'll try. Try to get the delta L. Okay, delta L. Everyone see this. Put this focus. The delta L equal L1 alpha delta theta. Now L1 is 2 meter. The alpha value is 5 into 10 to the power minus 5. 10 to the power minus 5 per Kelvin. The temperature difference 30 to 50, 20, no? 20 Kelvin. Now per Kelvin to per Kelvin cancel out. Now 2 into 5 it is 10. 10 into 20 it is 200. 200 into 10 to the power minus 5 meter is coming. Then 200 into 10 to the power minus 5 means 1, 2, 3, 0.002 meter. If you can't do this calculation manually, please use calculator, no problem. Okay. You can calculate, calculator, you can add 2 into 5 into 10 to the power minus 5 into 20. 0.02 meter is the delta L. 0.02 if you that is a from a standard unit. If you can't imagine what is the size, you can convert into centimeter. 0.2 centimeter or millimeter to only 2 millimeter. Only 2 millimeter is increasing when temperature increase up to 50 Celsius. You can imagine it is very small value. 2 millimeters which are very. Okay, that's the actual way. Actual thermal expansion. Okay, I got the value. Dihini. Okay, now can you get the delta L? Sorry, L2, L2. L2, delta L you got. L2. How we get the L2? Very good. Now you don't need another any equation for to get the L2. The L2 equal L1 plus delta L. No? The delta L you already got. Then L1 is 2 meter plus the delta L is 0.002 meter. Then 2.002 meter is the delta L. Sandeep, I got this part 2. Okay, please, if you have any doubt, please ask. If you want, you can try with L2 equation, you can try. The same answer is come. Same answer is come. Amina, what happened? Understood? Okay, good. Okay, then that's all about linear expansion. From next day, we practice more 2 questions in linear expansion and directly move into our area expansion and continue and complete the expansion fully in next week. Therefore, don't miss. If you're missing, the heat lesson will be very difficult. Now you already know it is going as a series. like a same story. Okay, the second part of the story will be in next week. Okay, that's all for today. I think if you have any doubt, we have now the time is up. Okay, good night. We'll meet next day, next week.